Alright, let us go into the last question of this class exercise, page 227, question number 4. So we are to use integration by parts. There's a formula, and we are to follow this guideline yet, such that here we have algebra and here we have inverse. So between A, algebra, and inverse, the inverse comes first, meaning the appropriate U is the inverse. So if we take the U to be the inverse and the remaining T dt to be the dV, so then to use this formula integration by parts, to get to that du, we need to differentiate. And here, how do we differentiate that? We look into your formula list, okay, such as this one. The derivative of inverse sign is 1 over square root 1 minus u square. Our u, that is the t square minus 1. We need to differentiate further the t square minus 1, which is 2t. Alright, so that is the du. As for this part, the dv, we integrate both sides, so we get the v, and integrating t with respect to dt is t square on 2. Okay, we get that correct. So normally here it carries 2 marks, choosing the correct u and dv and integrate and differentiate correctly. So then into the formula, okay, that is the formula, so we just quote the formula. Okay, so there's a m1 there, and if you can look there, there's a t cube. Okay, as we simplify here, replacing the v, okay, correct, du, this thing, and we got t cube. It's quite complicated, right? And here I'm trying to use a simple u substitution. I call it y, but if we let this, the function there, okay, I'm taking this portion t square minus 1 to be dy. Okay, so if this is the y, and we are to replace everything there, the t, in terms of dy, we need to differentiate. So we get dy dt being 2t, and what is dt that we are to replace? dt is dy on 2t. Alright, okay. So up to that, we still have this y, and there is still remaining of this t. Okay, so what is the t square? T square is 1 y plus 1. Okay, so do not integrate with two variables. We have to replace further the t square. So as we replace further the t square, y plus 1, so we need to integrate. So it looks complicated, right? So let's solve this first portion, or this portion of the integral. How do we integrate that? So why don't we pause the video, okay, and people try to solve this integral, okay, whatever method that you find that is suitable. Okay, let me pause this. Let me give about 3 minutes. You try this first. Okay, 3 minutes from now. So let us compare answer. Alright, so here I tried first using a simple substitution straight away, setting u to be 1 minus y squared, but you cannot replace the y in terms of the u, meaning you cannot get rid of the u. So a simple u substitution does not work, meaning you cannot simply use the u substitution straight away. Okay, unless you consider to expand. Here we can expand it like this one and this one. Okay, as we expand, you have to expand it first, and then only you can do a simple u substitution. Okay, for this portion, because there's a y dy there, as we say that the denominator value being a u, okay, 1 minus u square. And then here when we differentiate, okay, we get a nice negative 2y, okay. So dy is the du over negative 2, meaning we can replace everything in terms of the u. So there we have this 1 over square root u, or u power negative half. You can easily integrate, okay. So you will get the 2, and over here over 1 2 can cancel off. So you have a remaining of the square root u. And what is u just now? It is 1 minus u square. I'm replacing it back. And then for this portion, we have to use this formula given in our formula list. When we have a format of a square, a is a constant, minus variable u square. Okay, our a here is 1. Our variable here is y, dy. Okay, so we can easily quote the answer, which is inverse sine u, which is the variable. Our variable here is the y over a here is 1. So there we get the answer for this portion. So normally how many marks? So we have to expand it first, and then we are using a simple u substitution. We are integrating, okay, accordingly, and that is the answer for this portion, right? Okay, so let's substitute this answer back into the question earlier. Okay. So for this question that we solved just now, I'm putting back the answer, okay, over here. So we are replacing the values there, okay, for this portion. We replace it, and then we are to substitute back the y. The y is the t square minus 1, okay. And then here I'm trying to factorizing it, okay, because I can see that there's an inverse with 9 t square minus 1. So this is t square on 2 minus half, so t square minus 1 of it, okay. So there, replacing the values, okay, replace it back in terms of the t, and that will be the last answer. Right, how many marks do this question carry? So a question like this can carry 8 marks. Here there is no mark for the answer because we don't want to give too much mark for answer, because if this answer is wrong, definitely this answer will be wrong, right? And there are so many marks for the method. Make sure that you show all your work. So this is one way to solve your question number 4. Alright, okay. So let me show to you another way. Basically, I have an alternative solution for this question 4. Right, so this is our question number 4 just now. So when I see the t dt there, I try to simplify the question. Okay, so if you are to simplifying the question, for example, a very simple u substitution, I call it x. Okay, x is t square minus 1, so we need to change everything in terms of the x. And because here we have a t dt, as we differentiate to t, meaning t dt is dx on 2. So dx on 2, the 2 is a constant, we can put it up front. So there you see, now the question becomes more simple, isn't it? Okay, so, and then here we are to use IBP. Okay, so let's set the u to be the inverse come first. Okay, so M1 choosing, or actually S1 choosing the correct u and the dv. Okay, dv is the remaining dx. Half I put it outside. So derivative of the inverse, we have to look at the formula list is given, and here integrating both sides. So M1 for you to differentiate and integrate. Right. And then the question now, this question in terms of x, using the IBP formula, integration by part. Okay, we just substitute the values, the u, the v, and integrate v again and du, and then we are stuck with this. So to solve for this integral, I'm using the simple u substitution. I call it y. Okay, so for the method, to replace everything in terms of dy. So we need to differentiate dy dx, which is negative 2x. And here we have x dx. X dx is dy on negative 2. So here negative become plus. Right, so then we have one term only. So we integrate. Okay, now we can integrate only if we have a one term value. So it become y power negative half plus 1, which is half over the half. Okay, integrating, and then we replace. Okay, but here we are simplifying the question. Maybe there's an M1 mark there for you to simplify in terms of a simpler question now. Okay, so let's count how many marks does this carry. Okay, M1, the y in terms of x, but we cannot leave in terms of x, right? Because the question given as a t, we need to replace again the x, which is the t square minus 1. Alright, and you can find this answer is similar to the first alternative question that we have. Alright, so compared to your work, that is question number 4. Okay, thank you.